Hi everyone, Rohit here. Welcome to CADverse. In this tutorial we are going to learn about how to model and assemble a knuckle joint in FreeCAD. Let's get started. I hope you guys that you are familiar with the knuckle joint. A knuckle joint is a temporary mechanical joint used to connect two rods under tensile load while permitting limited angular movement between them. It is commonly applied in tie rods, suspension linkages, control mechanisms, and more. A knuckle joint mainly consists of 5 essential parts: fork end, eye end, knuckle pin, collar, finally, the tapper pin. So let's not waste any more time in getting started with knuckle joint tutorial. Open a new file from the home menu. This action will lead to the part design workbench. I just relocate the taskbar from the combo view panel to the right side of the workbench for the easiness of the work. Save the file in your computer. The first part is to be drawn is that the fork end. To create this, you should start with a 2D drawing. These are the two orthographic views of a fork end: front view and top view. You should select the most appropriate view for start drawing. There is no fixed rule for that. However, engineers follow a clear logic to select the most appropriate view. Here, I selected front view to start drawing. Create a body from task panel and create a sketch. Select a plane which you want to be draw the sketch. I select the XZ plane as a front plane. Click OK to continue. Draw the rough figure of front view by using drawing tools. I just started to draw the arc. Its center is same as the origin. Select the line tool to connect these arcs. You can also use the polyline tool to draw continuous lines. Preliminary sketch is now completed. Next step is to constrain this sketch by constraint tools. Always use geometric constraints before dimensional ones, because this reduces the number of dimensions required and improves sketch stability. Make this line horizontal by applying horizontal constraint, and make these points vertical. These two arcs are equal in length. Apply the constraint equal to do this. OK, geometric constraint is now completed. This is the time to apply dimensions to the sketch. Give the proper dimensions as shown in figure. You notice that some of the lines are turned into green, indicating that it's fully constrained. However, 1 degree of freedom is still there in the sketch. This point does not coincide with the y-axis. To make this, select both point and y-axis and apply constraint coincident by simply pressing C in your keyboard. You can now see that the sketch is entirely green, meaning that it's fully constrained. You can close it by clicking on the corresponding icon. Find the pad tool from the right side of the window. Click on it. This action will turn the sketch into a 3D object. Enter the required length here. You can find the dimension from the top view. It's 48. Also click this checkbox to make the body symmetric to the XZ plane. Click OK to proceed. Select the face on the top of the body and create a sketch on it. Press 2 to turn the body if need. Sketch the top view as shown in figure. To do this, select the external geometry tool and mark the left and right edges of the body. Starting with the center circle tool, draw a circle. The center of the circle is aligned with the x-axis. With Create Arc by Center tool, draw an arc using the center of the circle. By using the Line tool, draw a line from the arc to the projected line. Repeat the same process for the bottom line. Create a loop outside the sketch by using the Polyline tool. Select the Fillet tool and make a fillet by simply selecting the both line and arc. Do the same as bottom also. Apply geometric constraints and dimensions to the sketch to make the sketch fully defined. Make these 2 points symmetric about the x-axis. Make these 2 arcs same in length by applying equal constraint. Apply the proper dimensions as shown in the figure. All the geometric constraints have been applied to the sketch, resulting in a fully defined profile. The sketch is now ready for the next step. Through a pocket operation, we will get the final result. Under this drop-down menu, select the Through All option. Congratulations, you have completed the 90% of the work. Click OK to proceed. The next step is to model this transition feature. We start by applying a chamfer on the edge, followed by a fillet operation to achieve a smooth and realistic geometry. To do this, select this face and create a sketch on it. By using the external geometry tool, project any of the 2 adjacent edges of the rectangle. And draw a triangle at the edge of the rectangle with the help of reference line. The length of the 2 sides of this isosceles triangle is 8.2 millimeters. Once the sketch becomes fully constrained, you can go to the next step. After completing the sketch, we apply a pocket operation. This operation removes material from the body up to a defined depth. Once the pocket is executed, the model updates to show the final geometry. To make a smooth curved surface here, select the corner and apply a fillet feature. Fillet operation replaces a corner with a curved surface of a defined radius. A fillet distributes stress more evenly, improving the mechanical strength and fatigue life of the part. Keep in mind. Click OK to continue. We have to do the same process at the remaining 3 edges of this rectangle. To make it easy, Polar Pattern tool is used. This tool is used to replicate a selected feature multiple times around a specified axis. Select the pocket and fillet operation from the model tree, then select the Polar Pattern tool. Specify the total number of occurrences in the Polar Pattern operation. Here, I give 4 occurrences. As a result, each copy is placed at the same angular spacing, giving a perfectly symmetrical circular pattern. The next step is to model this cylindrical shaft at the end of the knuckle joint. This shaft is created by sketching a circular profile on the end face and extruding it to the required length. Select the face and create a sketch on it. Draw a circle of 25 mm here. Extruding it to the required length by using the pad tool. Now, the sketch is almost completed. The final step is to model this inclined surface at the edge. This is created using a chamfer operation. The chamfer removes the sharp corner by cutting it at an angle, which improves assembly and reduces stress concentration. In FreeCAD, we uses the revolve cut feature in order to obtain this result. Let's see how to do this. Select the Create Sketch tool from the toolbar. On the pop-up window, select the XZ plane to draw the sketch. By using the External Geometry tool, make a reference to this edge. And draw a triangle here with an angle of 60 degrees and height of 10 mm. Close the sketch. Select the Groove tool option from the task panel. It removes material by rotating the sketch around the x-axis. Under this drop-down menu, axis is changed into horizontal. Click OK to continue. Now, we have successfully completed the fork end of a knuckle joint. The next part is to be drawn is at the end. In this session, we covered the key operations like pad, pocket, fillet, and groove. In the next video, we will continue with the remaining components of a knuckle joint. Thank you for watching.